Okay, we ready? Good. I would like to talk about Swiss machining today, and I will start with some general information which is available in a brochure if anybody wants to grab one. Nomura has been in this kind of industry for a long time. First machine was produced in 1935, which at that time was a cam-operated piece of equipment. And very quickly that transits to the CNC, which is around 1970. And today we have, you can see several different models, different sizes. Now, we emphasize with this product heavily on making it as much as productive as possible. What we mean by that, having consistent sizes, being able to change over faster, more chip removal. To make a long story short, what we like is to have as many parts, good parts, in the basket at the end of the day. And for that, there's some really specifics on this equipment which is important to us. Notice that every machine has a white cast iron base. We do keep the coolants inside the base. The purpose of that is, number one, to minimize any kind of vibration which can be generated in the machine. Also, the coolant inside the base would give you a more stabilized temperature. Because as everybody knows, if you have variation in temperature, you have variation in size, and you want to properly control that. So this is the reason of the one piece cast iron based on this equipment. Also, again, if anybody wants to look in the brochures, we are the only ones still who make the machine with what we call dovetail hand-scraped slides. So that's really the old-fashioned way to make machine tools. We're going back many years where people were making the first machines. Didn't have any fancy grinding equipment, so they had to scrape the slides. We still do that on this equipment. Again, reason, make the machine more sturdy, being able to hold tighter tolerances and better finishes. So many times, situations where a component needs to be ground secondary can be completed on this equipment. Also, to make the machine productive, and we could maybe take a shot at that, we still offer what we call a tool presetter. A tool presetter allows to set the tools outside the machine. Now also, we know well that other brands recommend what we call the touch-off. Touch-off brings the tool to a specific dimension which is registered by the machine. Touch-off does not check your heights on your tool. On a presetter, you check the heights of your tool. Very key to have accurate parts and be able to change over fast from job to job. Now, I will be more specific on the machines we are showing here. Here, this is what we are making. Fairly big parts. The operations, which is, I would not say difficult, but more impressive, is the fact that we are drilling the whole part through with a drill. This is a 38 millimeter machine which can go up to 42 when you use it as what we call a chucker mode or guide bushless mode. And you will also notice that the size of the piece of equipment is in proportion of the dimension of the spindle. It's not a piece of equipment which used to be a 32 and then suddenly becomes a 38. The whole machine has been dimensioned for this kind of size. Just to give you an idea, this machine, the weight is close to 8,000 pounds. Now we are looking at what we call our 32 millimeter YB3 XB. And on that machine, if you maybe want to take a shot inside, over there. In here we have what we call the B-axis. Again, this B-axis is quite unique because it has 5 live tools which have ER20 collets where you can fit a 1/2-inch cutter in it. We have on the opposite side, looking towards the sub-spindle, another 5 live tools. On the side of the live tools, you have static stations, 5 of them. And, of course, the opposite of these live tools, you can see the turning tools. This machine has up to 39 tool stations. We are making on this machine a fairly simple part, but an operation which can allow it again to make something complete. We have a gear, which we hub, with a gear hub in the machine. And then we have a burning operation, which on this type of part is many times required to improve the finish and also size it. And this is what we're making on this. This is a smaller piece of equipment. It goes up to 20 millimeter. The configuration of this machine is very busy on the back side of the equipment, what we call the sub-spindle. And this is what we show here, okay? The reason of having many tools on the sub-spindle is because when you decide to run a job on a Swiss, it's always a problem sometimes when you have the larger diameter, which I will say is on the wrong side. Because on the Swiss, you have to feed out the part a certain way to be able to grab it when you do your cutoff. Now, if the busy portion of the part is unfortunately not on the right side, you end up having not enough tools to complete it with the sub-spindle. And you can see on that component, that part here, it's very symmetric, and it shows that you can do as many operations on a main than you would do also on a sub-spindle. So that allows you to complete a part. Now we go to this one. That's a 10 millimeter machine. Of course, RPMs 15,000 on main, 15,000 on the sub. Live tools, RPM is 10,000. What is unique on this equipment is the design of the tool holders. They're very similar to what we have on the bigger machines. And if you would like to come over here so we can exactly show what it is. These tool holders are mounted on 2 pins where the holder can slide. We can mechanically change our Z position on that machine. The reason we would like to have this kind of feature is because where small parts meet small stock size, when you have operations like milling a flat or putting a cross hole in the part, and your live tools are too far from your bushing, you will have to feed out your stock to be able to perform this operation. What happens is that many times your material will flex, move away, so you lose your accuracy when you do this kind of operations. On this equipment, you can put into the machine what we call extended bushing, which brings you closer to the live tools, and we can accurately move our turning tools. So we will be much better conditions to do this kind of operations. So that's unique. And same thing again, these tool holders can come out of the machine and are preset on a tool presetter. Because again, if you have very small stock, very small part, what is critical is to keep your tool in center line. There also machine, you cannot check that. On that one, you do it outside the machine, you put it in, and you be sure that it's exactly on center line of your part. So this is one of the special features we have on this equipment. I would like to say a few words about the control we are using. It's Mitsubishi. We prefer this kind of control for many reasons. First, it allows you to select which spindle you're using. There's a customer up in Wisconsin one time used his Swiss machine to do secondaries. What he was doing is to load the blanks into the sub spindle and then start the cycle time, because you can activate which spindle you want to use. If it's $1, it's the main spindle. You activate $2, it will be your sub spindle. Also, what is different is that when you set up a job, and for some reason you need to stop the machine, you will realize that your chips are packing up and you have to stop. With your override, you can stop the machine. You can stop your main coolant. You can stop your spindle. You can clean up the machine. You restart your spindle. You restart the coolant. And with the override, you keep going with the machine. So on other equipment, what will happen, as soon as you go into MDI to do anything else, it will reset your program and chop off your part. If your cycle time is 30 seconds, it doesn't matter. We have applications today where the cycle times are 10, 12 minutes. There's a difference. People don't want to wait to have a part complete before you can check it. So, don't know if anybody has any questions. I don't know if I covered it all. You're good? Thanks very much for your time. I appreciate it.